Have you ever looked at a hydrangea bush and just wondered, how can one single plant be a living kaleidoscope, bursting with pinks and blues and purples, sometimes all at once? Well, it's one of gardening's most fascinating mysteries. So today, let's dive into the incredible science behind this amazing floral magic trick. I mean, look at this. This is exactly what we're talking about. You've got these deep, rich blues right next to these vibrant pinks, all growing on the same plant. So how on earth does it do that? Is it some kind of garden magic? Or is it just chemistry? Well, spoiler alert, it's chemistry, and that's what we're going to break down right now.
For years, gardeners have known about the first piece of the puzzle, and it starts right under our feet, in the soil itself. The very first clue to solving this whole mystery is a simple measurement, the soil's pH.
Now, the rule of thumb seems incredibly simple, right? If your soil is acidic, you get blue flowers. If it's more on the alkaline side, you get pink ones. This has been the go-to advice for ages, and honestly, it's a fantastic starting point. But as we're about to find out, it's not quite the whole story. And if we zoom in a bit, you can see the specific ranges where the magic happens. For those really true blue blooms, you need some strongly acidic soil, something with a pH below 6.0. Then, as you creep up toward neutral, that's where you start to see those beautiful purples, and once the soil tips over into alkaline, everything shifts to pink. But this just brings up another question, doesn't it? What is the pH actually doing? And here is our plot twist. This quote really gets to the heart of it. It's not the pH itself that's painting the flowers. Not at all. Instead, the pH is basically the gatekeeper. It's controlling the availability of something else, a secret ingredient that's already hiding in the soil. Which brings us to the real star of the show, aluminum. Yep, this single element is the true artist behind those brilliant, breathtaking blue hues.
So here's the best way to think about it. The soil pH is like a key. A low, acidic pH turns that key and unlocks the aluminum that's already in most soils, which makes it available for the plant to actually use. So the pH isn't the paint, it's the thing that opens the door to the paint supply. So the whole process really goes down in 4 clear steps. First, the soil becomes acidic. That chemical change releases those aluminum ions. Then, the hydrangea's roots can finally soak up all this newly available aluminum. And from there, the plant's internal plumbing acts like a superhighway, transporting it all the way up to the flower petals.
Okay, so now we know how the aluminum gets into the flower. But what happens once it's there? To really get that, we need to zoom way, way in and look at the chemistry that's happening on a molecular level, right inside the plant's cells. All right, I want you to meet the hero molecule of this story, anthocyanins. Now, these are the very same pigments that give things like blueberries and red cabbage their vibrant colors. They're naturally present in hydrangeas, just kind of waiting in the wings for the right conditions to show their true colors. But, and this is a big but, for a hydrangea to even have the potential to be blue, it has to be born with the right stuff. It needs a very specific type of pigment called delphinidin. So this is a crucial piece of the puzzle. It all starts with a plant's own DNA. And there it is, the simple formula for a gorgeous blue hydrangea. Inside the flower's cells, those aluminum ions we've been tracking finally meet up and bind with the delphinidin pigments. This little chemical reaction creates a stable, complex molecule that reflects blue light right back at us, giving us that stunning, deep blue we all love. Okay, so now that we've completely geeked out and cracked the chemical code, let's get practical. How can you take all this science and use it to become the artist of your own garden, literally painting with hydrangeas? It's a pretty straightforward 3-step process. First, get yourself a simple soil test kit so you know your starting point. If you need to make your soil more acidic, you can add a soil acidifier. And then finally, to make absolutely sure that key ingredient is there, you can add some aluminum sulfate, which conveniently both lowers the pH and provides that crucial aluminum. You can find products just like this one at pretty much any garden center. They're specifically designed to help you create that acidic environment. Just, make sure to follow the directions on the package carefully. And hey, a few final tips for your color-changing adventure. If you're actually aiming for pink, well, you just do the exact opposite. Add some garden lime to raise the pH. That locks up the aluminum. And remember, be patient. This isn't an overnight thing. And this is really important. This trick only works for big-leafed and mountain hydrangea varieties. Others, like the oak leaf or PG types, they're not going to change color this way. So we've pretty much solved the blue and pink puzzle, but there are a couple of other really common color questions that always pop up. So let's tackle these final riddles to complete our understanding. This is a super common one. You have a beautiful blue or pink hydrangea, and then, late in the season, the blooms start to get this kind of greenish tinge. Did you do something wrong? Is something wrong with the soil? Nope, it's not your soil. This is a completely natural aging process. As the flower gets older, those vibrant anthocyanin pigments just start to break down. When they fade, what's revealed is the sepal's natural base color, which is green because of chlorophyll. It's just a sign that the bloom is reaching the end of its life for the season. So what about those hydrangeas that are always a crisp, clean white, no matter what you do to the soil? What's their deal? The answer here is actually super simple. Genetics. White hydrangea varieties are just born that way. Their DNA doesn't have the instructions to produce those anthocyanin pigments at all. So without any pigment to interact with, the aluminum has nothing to do. The flowers stay white, no matter what your soil's pH is. So, when you see a vibrant blue hydrangea, you're not just looking at a pretty flower. You're actually seeing the results of this beautiful and complex dance between the plant's unique genetics, the acidity of the soil, and of course, the hidden power of that key ingredient, aluminum. And that really makes you wonder, doesn't it? The hydrangea reveals this incredible chemical story right before our very eyes. It kind of leaves us with one last question. What other amazing secrets of science are just waiting to be discovered, hiding in plain sight, maybe even in your own backyard?